Okay, this is problem number. I made videos of the ones before this. But anyway, this is problem number 10 off of exam 2 review. And here we are. We has the graph of the derivative of a function f is given below. Use the graph to determine each of the following. And intervals where f is increasing and intervals where f is decreasing, the relative maximum points of f and the relative minimum points of f. Remember, this is the graph of f prime, the derivative of f, not the graph of f. So we can't say, well, f is increasing from, this looks like, I don't know, -1 to 1. You can't say that. This is not the graph of f. This is the graph of f prime. But we can tell ourselves things about where f is increasing and decreasing by looking at the graph of f prime. And the way I like to do it is to go back to my comfort zone, which is to look at the sign of f prime and how it what it tells me about f. So when I talk about the sign of f prime, I'm looking for where it's positive and negative. Where it's positive and negative, or it changes from positive and negative when it crosses the x-axis, if I'm looking at it graphically. So this is f prime. It crosses the x-axis here at -2. So I have that on the graph on here. It crosses it's 0, I should say. It doesn't necessarily have to cross the x-axis. It's where f prime is 0, and f prime is 0 here at -2. It's 0 here at 1. So it's another little point, and it's 0 here at 1, 2, 3. When I blew this up, it doesn't look quite as good as it did earlier. But anyway, on the other one, but you get the picture. You can count these little tick marks. So that's, what do we say, -2. Oop, I need to get out of that. Put back on the paintbrush. So here we go. This is -2. This is 1, and this is 3. So is f prime positive or negative? To the left of -2. Well, is it above or below the x-axis? Well, it looks like it's above the x-axis to me, so it's going to be positive in that interval. Between -2 and 1, is f prime positive or negative? Well, if it's positive, it'll be above the x-axis. If it's negative, it will be below the x-axis, and it appears that it's below the x-axis to me. So that's negative. And then from -1 to 3, well, it still looks like it's below the x-axis, so f prime is negative, and then it is positive from 3 to infinity. So it's positive. Ooh, that didn't come out too well. Anyway, it's positive. And what does that tell us about f? Well, if f prime is positive, then f is increasing. If f prime is negative, then f is decreasing. If it's a negative again, and then increasing, it's still negative. Just because it equals 0 doesn't mean it has to change. So we're pretty much ready. And you don't have to use this method that I've detailed right here. Some people look directly at the graph and just go right to this, but I kind of like to go back to my comfort zone, and this is usually what you're shown in the book, so that's just what I do. Intervals where f is increasing, well, it looks like from -infinity to -2, and from 3 to positive infinity to me. And then from what I did right here, it looks like that. Where it's decreasing is from, it's really -2 to 3. You could break that up, but I'm just going to say it's from -2 to 3. And relative maximum point will be where f goes from increasing to decreasing. Well, you don't really know what the point is. You can't really evaluate it, but you can say -2 f of -2. You can describe it as a point like that, and that's the kind of why I've been doing it before. And then a relative minimum points where it goes from decreasing to increasing, and I'm going to say that is 3 f of 3. And I'm just going to put a little or right here that you can, if you want to, you could write this -2 to 1 and 1 to 3. And honestly, I think that would be a little safer because I don't know. I mean, you really don't know what f looks like, but I doubt that this is if this was f prime, well, I made this function so I know it's a polynomial, so I know it's a function it's a derivative of is a polynomial, so I could definitely say this is continuous, but I don't know. I guess if you had some kind of like x plus 1 over the cosecant or something like that, I don't think its derivative would look like this, but you would. My point is you would have points of undefinition in the original function that wouldn't occur in the derivative sometimes. It's odd when it does, but anyway, I don't know. I think it's debatable. So the main thing is how to look at graph of f prime and how to tell what f is doing from the graph.